Hello guys, hope you all are doing well. So today's topic is combined translation and rotation. So basically in this part what we will discuss that a body is having translational motion as well as rotation. Okay. So let us assume a body, a rigid body. This body is rotating with some angular velocity omega and it is having some velocity VA in the forward direction. For this point we have represented its velocity VA. Now one by one we will talk about rotation and translation. Let us assume that if this body will not having or this body have not any rotational motion, it has only translational motion. In that case all the points on this body must move in the forward direction with the same velocity VA as it is rigid. So from here we are considering another point B and the position vector of this point B is RBA. The position vector of this point B is RBA. Now for this point B, due to translational motion, it will have a velocity VA in the forward direction. Is it okay? Now if it is rotating also, so due to rotational motion it will have a velocity along the tangent and that velocity will be omega vector cross r vector. So what we are finding out that this point B is having a velocity VA due to translational motion and this body B has got a velocity omega cross r along the tangent, okay, due to rotational motion. One more thing I would like to tell you that if you will observe the point B with respect to A, that means if you will fix yourself at A and observe the point B, you will find that B is performing circular motion with respect to A. Got my point? So in that case you will find out the velocity of point B with respect to A, that is VBA. What I am trying to say that if you will observe the velocity of point A with respect to, if you will find out the velocity of B with respect to A, that means you have fixed yourself at A and observing B, you will find B is performing circular motion, and if it is performing circular motion then the velocity of this point will be omega vector cross r vector. Is it okay? Now this VBA can be written as VB vector minus BA vector and this is equal to omega vector cross r vector. So the velocity of B with respect to ground will be omega vector cross r vector plus BA vector. Is it okay? Is it okay till this? Again I am making you very clear about this, that this body is performing angular motion or rotational motion as well as it is performing translation. First of all, we are not taking consideration of this rotational motion, we are just talking about the translation. If any point on this body has got velocity VA, then all the points on this body must have velocity VA in the same direction. Is it right? As the body is rigid and it is performing translation. Now what we have considered a point A and that point has got velocity VA in the forward direction and another point B which has got a position vector RBA, that is position vector of B with respect to A. So for this point B, what we will find, if you will observe this point B from A, क्या बोला, कि अगर आप B को ऑब्जर्व करते हो पॉइंट A पे बैठ के, यू विल फाइंड दैट दिस पॉइंट B इज परफॉर्मिंग सर्कुलर मोशन. And if it is performing circular motion, then in that case velocity of B with respect to A can be written as omega vector cross R vector, and this R is not only R, this is RBA, position of vector of B with respect to A. Okay. Now this VBA can be written as VB minus BA, and this equation can be further solved like this. Okay. Now to clarify, we are considering a disk. So let us suppose a disk. The disk has got radius R, and the points on this disk A, this point is named as B, this is C, and this point is D. Okay. Now this center, the center of mass of this disk has got some velocity v com. Okay. Along with that, this disk is again rotating with some angular velocity omega. Got my point? This disk is again rotating with some angular velocity omega. Again, what we are observing, that this disk has got some velocity in the forward direction, along with that it is rotating about some axis. Is it okay? Now we want to find out the velocities of the points A, B, C and D. If you want to find out the velocity of all these points, this diagram can be drawn Now let us say this point A, we will first talk about this point A. Now this point A, if you will observe, as the center of mass of this disk has got a velocity v com due to its translational motion. So this point A will have a velocity in this direction, and that will be equal to v com, and this velocity is due to translational motion. Again, if you will observe, due to this rotational motion, this point A will have a velocity in this direction again, and that velocity will be written as omega vector cross R vector. Is it right? So this is velocity of A, and this velocity of A can be written as velocity of center of mass plus omega vector cross R vector. Am I right? Now if we will talk about this point will have again a velocity v com in this direction. This is v com, and due to rotational motion, it will have a velocity along this direction, and that will be written as omega vector cross R vector. Now how you have mentioned the direction? As this disk is rotating in clockwise direction, the omega will be into the plane of the board. So this is omega vector, and in this direction is R, so omega cross R will be in the downward direction. So I have represented omega cross R like this. Now if you will observe this point will have velocity v com in this direction, and along with that it will have a velocity in the backward direction, and that will be omega cross R. Again the direction can be find out using the cross product. Now if for this point D, this point will have again a velocity v com in the forward direction and a velocity in this direction, and that will be omega cross R vector. Okay. Now to simplify this, what we can write, this diagram where the body is translating as well as rotating, we can divide the diagram into two parts, one in which the body is only translating. So, let us say this center is having some velocity VCOM, and the another diagram in which this body is only rotating with some velocity, angular velocity omega. Okay. Now, if you have drawn like this, so this due to the center of mass, due to the velocity of center of mass, all the points will have velocity in this direction VCOM, and this point will have again a velocity VCOM in the forward direction. Now, due to this rotational motion, all the points, this point A will have velocity in this direction omega r, this point B will have velocity in the direction omega r, this point will have velocity omega r, and this point will have velocity in this direction, and that will be omega into r. Now, combine these two diagrams. After combining, you will find the same diagram whatever we have drawn in the above part. Got my point? So, what we need to do whenever we are finding a problem in which the body is translating as well as rotating, in that case what we need to do, we need to convert the diagram into two parts, one in which we will only represent the translational motion, and the next part in which we will represent only the rotational motion. Now, drawing the diagrams we need to represent the velocities of all the points. Okay, we need to represent the velocities of all the points in translational motion as well as rotational motion, and after that superimpose both the diagrams, you will get this. After few time you will observe that you can directly calculate, you need not draw the diagrams or do mathematical calculation, you will find just that easily you can calculate the things, the velocities. Okay. Now, say a body, this point is A, B. Okay. Now, the radius of this disc is r, whatever it is, disc or a sphere, say its radius is r, and the center of mass of this body has got some velocity u in the forward direction. Again, this body is rotating with some angular velocity omega. Okay. Now, in the previous part we have discussed about the velocities of points A, B, C and D, but if we need to find out the velocity of any general point, say this general point is P. Okay. What we want to find out right now in this part is the velocity of point P. Say this line is making angle theta with this radius vector. Now, if you will observe this point, you will find that due to translational motion, this point P, due to translational motion, this point P will have velocity Vp in the forward direction. Is it right? Along with that, this body is performing rotation. So, this point P will have a velocity in this direction, and that velocity will be represented by omega vector cross r vector, and that will come out to be along the same direction along the tangent. Is it okay? Now, this line is making angle theta with this. Okay. If we will superimpose both the diagrams, what we will find out that this diagram can be drawn like this. this point P has got a velocity in this direction, and that is u. This point has got velocity in this direction u, that is due to the velocity of center of mass, or due to translation it has got velocity u in the forward direction. Along with that, it has got a velocity in this direction, and that is omega r. Now, as we were given that this line was making an angle theta with this, so you will find that this angle is 90 minus theta, this is 90. So, this angle will be again 90 minus theta. So, from here we can write this angle, the whole angle, that is the angle between the two vectors. I am drawing the diagram over here. This is u, and into this direction we have omega r, and this angle can be written as, this is 90 and this is 90 minus theta. So, this is 180 minus theta. Is it okay? What we have seen, that if this angle is theta, this will be 90 minus theta, and this is 90. So, the whole angle will be 90 plus 90 minus theta. So, 180 minus theta. Now, we need to find out the resultant of these two vectors, u vector and omega r vector. If we will find out, we can write it like this: u square plus omega square r square, okay, plus 2u into omega r into cos of 180 minus theta. Under root. So, this will be the velocity of the point P. Okay. Now, this is about velocity. This is all about velocity. Now, what if the body has got some angular acceleration? Say, the disk, again we have considered this disk has got radius r, and the center of mass has got some acceleration a. Along with that, this is having some angular acceleration alpha, and it is rotating with omega. Got my point? Again we have considered the disk, and the center of mass of this disk has got acceleration a. Alpha is the angular acceleration and omega is the angular velocity. Got my point? Now, for any point, say this point, for this point, if we will try to find out the acceleration, due to the acceleration of center of mass, it will have a acceleration a in the forward direction. As this point B is performing circular motion with respect to the center of the disk, what I told you, that with respect to the center of the disk, this point B is performing circular motion. So, it must have a acceleration in this direction, and that will be omega square r, that is centripetal acceleration. Again, due to this alpha, it will have acceleration along this direction, and that will be r into alpha, since earlier we have talked about tangential acceleration at is equal to r alpha. In the same way, we can represent the acceleration of all the points. If we will draw the acceleration of this point, you will find out this point has got acceleration in the forward direction a. Due to centripetal acceleration, it will have a component in this direction, that is omega square r, and acceleration in the tangential direction, and that will be r alpha or alpha into r. So, again if you want to find out the acceleration of all the points, you can convert this diagram into two parts, one in which the body is only translating, that is it has got acceleration, its center of mass has got acceleration a in the forward direction. Along with that, you can draw its rotational motion, that is it is performing rotation with angular velocity omega, angular acceleration alpha. Is it okay? Now, if you will observe the acceleration due to translation, all the points will have same acceleration in the forward direction A. Along with this, due to this rotational motion, all the points will have a acceleration omega square r towards the center and an acceleration r alpha in the tangential direction. This point will have, this point will have an acceleration r alpha in this direction and acceleration in this direction, this will be omega square r. For this point you can write like this, r into alpha, along with that omega square r. For this point towards the center it will be omega square r, and in this direction it will be r alpha, and both the diagrams can be superimposed. And for any point, if you want to find out the acceleration of any point, you need to take the vector sum of omega square r, r alpha and a. Got my point? Clear? This is all about the kinematics. This is all about the kinematics of combined translation and rotation. What we need to do till this, we have discussed that whenever we are getting a problem in which the body is performing translation as well as rotation, we need to divide the problem into two parts, one in which the body is performing only translation and the other part in which the body is performing only rotation. After representing all the velocities or acceleration, what we need to do, we need to superimpose both the diagrams and take the vector sum. Got my point? You will find out the velocity, you will find out the acceleration. Okay. Now, we want to find out the kinetic energy. What we know, kinetic energy is the energy associated due to motion of the object. So, when the body is translating, it must have energy due to translation motion, as well as the body is performing rotation. So, there must be kinetic energy associated with the rotational motion. Am I right? So, for a body which is translating as well as rotating, say it is rotating with omega and has got some velocity u, so its kinetic energy will be written as half into m into u square. This is the kinetic energy due to translation. So, what I told you, that kinetic energy of the body when it is performing combined translation plus rotation, we need to write kinetic energy due to translational motion plus kinetic energy due to rotational motion. Got my point? So, kinetic energy due to translational motion will be written as half mu square plus the kinetic energy due to rotational motion will be written as I into omega square, and this I is I COM. Okay. So, whenever we need to write the kinetic energy, we will write the kinetic energy due to translational motion as well as rotational motion. In the latter part, we will discuss how to write the kinetic energy in a single term. Okay. The kinetic energy of translation as well as rotation will be written in a single term. Okay. But we will discuss that in later part. Now, the very most important part of this topic is pure rolling. Pure rolling or rolling without sleeping. Now what it means? What we observed in the previous part is the body is having some translational motion along with the rotational motion, sorry, omega. Now if let us say this surface is S and the point of this disc which is in contact is P. Now in order to have pure rolling or rolling without slipping, the point which is in contact, that is this point P, and this surface, that is velocity of P with respect to S, must be equal to 0, or we can say B velocity of P along velocity of P with respect to S should be equal to 0 along the surface. Got my point? What I mean to say, if you will observe this point S and P, say this point P will have some velocity u in the forward direction, as it is rotating again, so it will have a velocity omega r in this direction. Say this surface has got some velocity Vs, whatever may be the direction, I am just writing that this body has got some velocity Vs. Got my point? If this body has got some velocity Vs, in that case Vs must be equal to velocity of the surface must be equal to velocity of point P. That means there should be, that implies that there should be no relative motion, there should be no relative motion between the point P, between the point P and surface S along the surface, along the now concentrate on this part, along the surface. This means along the surface there must not be along the surface there should not be any velocity, but perpendicular to the surface there can be some velocity. Got my point? Perpendicular to this plane there must be some velocity, or there must be some acceleration. Again we can write there should not be relative motion. I have just left this point. There should not be relative motion between the point P and surface S along the surface. Okay. If you are writing this, that means acceleration of point P with respect to S, this should be equal to 0. Got my point? That is acceleration of point P, that must be equal to acceleration of point S. Is it clear till this? Pure rolling means the point in contact and the surface should not have any relative motion, should not have any relative motion. To make it more clear, we are considering an example. Let us say a disc. This point P, in the 90% of the cases we will find out that this surface is stationary, but but in few problems we will find that this surface is again moving, and in that case we need to consider that velocity of surface must be equal to velocity of point P, or velocity of S minus velocity of P, this should be equal to 0, and this must be along the surface. We are not talking about any velocity or acceleration along the, similarly we can write AS minus AP, this is equal to, this is all about along the surface. We are not talking about the direction perpendicular to the surface. Now see this point P, if this body is translating with some velocity v and it is moving with some angular velocity omega, and the body is performing pure rolling, what we are discussing about the pure rolling. Okay. If this body is in pure rolling, then this point P will have a velocity in this direction v, and due to rotation it will have a velocity omega into r in this direction. As the surface is stationary, surface is stationary. If the surface is stationary, in that case this S, that is velocity of surface, is equal to 0. That means velocity, that implies that velocity of point P must be equal to 0. Am I right or not? If this is the thing, or this is the point, so according to this point we can write the velocity of point P is v minus omega into r, and this should be equal to 0. So from here we can write v is equal to omega into r. So if the body is in pure rolling, what? If the body is in pure rolling, in that case whatever translational motion or whatever velocity the body has got due to translational motion, that must be equal to omega into r. Okay. Now consider another example in which we will consider the body is having some acceleration. Now here this is the body, and this body this point of contact P is again like this. The surface is again stationary, surface is stationary. If the surface is stationary and this disk has got a acceleration a, the center of mass has got acceleration a in the forward direction, and it is moving with omega and has got some angular acceleration alpha. Okay. Now again if we want to have pure rolling, then velocity of point P, this should be equal to velocity of surface. Am I right? Again what we should write, acceleration of point P, this should be equal to acceleration of surface. As acceleration of surface is equal to 0 implies that acceleration of point P must be equal to 0. Now if you will observe the acceleration of point P, try to observe the acceleration of point P. Due to translation, this point P has got acceleration a in the forward direction, in the backward direction it has got acceleration r into alpha, and as the point P is performing circular motion with respect to point A, it has got a centripetal acceleration, and that is omega square r. Got my point? Now as the acceleration of S is 0, acceleration of P must be 0, and another condition should be here, that is along the surface, along the surface. So if you are thinking, sir, what about omega square r? So omega square r is the acceleration of this point perpendicular to the surface. So we need not worry about this acceleration, we just need to consider these two acceleration, that is A and R alpha. That means A minus R alpha, this should be equal to 0, and in that case A will be equal to R into alpha. Got my point? So this is about pure rolling and the kinematics related to pure rolling. Got my point? How to find out the velocity we have discussed in the earlier part. How to find out the acceleration of any point we have discussed in the earlier part, and this is about pure rolling. And in pure rolling the acceleration of point of contact and velocity of point of contact must be equal to velocity of the surface and acceleration of the surface, or in other words we can say there must not be, or there should not be any relative motion between the point in contact and the surface and along the surface. This should be applicable, or this should be applied along the surface. As in this case we have observed that this body or this point P has got acceleration omega square r perpendicular to the surface. So this component of acceleration is not considered over here, as it is perpendicular to the surface. Got my point? Now let us say solve a problem example we are considering. Okay, what again we have considered a disk, and this point is a we want to find out a general formula. Okay, what we need to find out? We need to find out the general formula for any point when the body is pure rolling. So this body is rotating with angular velocity omega, and this has got, it has got some translational motion along this, and this u is equal to u in the forward direction. Now this body is in pure rolling, pure rolling. Got my point? So if this body is pure rolling, in that case we can directly write down that u is equal to omega r, u is equal to omega r. Okay, now we want to find out the velocity of any general point P which is making some angle theta over here. Okay, now if you will observe, this point will have a velocity u in this direction. I am drawing the diagram in another part so that it can be represented clearly. So this point is P and this angle is sorry, this point is P. Now as the center of mass of this disk has got some velocity u in the forward direction, so this point must have a velocity in this direction, that is should be u, and this point should have a velocity along the tangent, and that should be equal to omega into r, and as it is in pure rolling, so omega r, this should be equal to u. Now the vector diagram can be drawn like this: u, this is u, and this angle is 180 minus theta. Along with this we can solve the for acceleration also on this part. Suppose this point is P, this is making angle theta, this has got angular acceleration alpha. Okay, it is the center of mass has got acceleration a in this direction. In that case we can represent this point P will have a acceleration alpha r in the tangential direction, and in this direction it will have a acceleration a. Again the vector diagram can be drawn like this: this is alpha r and this is a, as it is in pure rolling, in that case A must be equal to R alpha, and here we can write A equals to R alpha. This angle will be again 180 minus theta. So the result is applicable to both of the cases, for velocity calculation or for acceleration calculation. Now if you will find out the resultant will be written as u square plus 2 u square cos of 180 minus theta. Is it okay? Now this can be written as 2 u square in common 1 cos of 180 minus theta. This can be written as minus of cos theta. So 1 minus cos of theta under root. This is the velocity of point P. So this can be represented, or further solving we will find out 2u sine of theta by 2. This is the velocity of point P. Now putting the value of theta for all the points what we had calculated A, B, C, D, putting the value of theta for all the points, you can find out the velocity of the points from this formula only. Similarly, you can write the acceleration of point P as 2a sine of theta by 2. Is it okay? So till this we have discussed about the kinematics of rotational motion, combined rotation and translation. In the next lecture we will discuss about the dynamics of combined rotation and translation. Till then, thank you, bye bye.